And the plural form of radius is radii. R-A-D-I-I, radii. Okay, you already know that though, right? This picture on the next section, D to E, is a segment with two endpoints on the circle. That's called a chord. Now there's one special chord. Shh, guys, I don't have time for your talking. Sorry. Just don't. One special chord that goes through the middle, or the center point A. What's that called? Diameter. So you already know that word. Maybe chord, if you're not, hopefully you remember it now. Okay, now for angles inside circles. An angle whose vertex is at center point A and extends, intersecting the circle twice. So the center of the circle is on the vertex of the angle. That's called a central angle. Don't flip over yet because we're going to add something on the bottom here. A central angle has a special relationship. Angle A, if I gave angle A, say 80 degrees, I have an arc, don't flip it over yet, we're not on the first page. An arc from B to F. If the central angle's measurement is 80 degrees, the arc measured 80 as well. So they are congruent. So the measure, that's called the minor arc. There are two arcs. We have the short little green one. We have the big black one on the outside. So the major arc is the big one. The minor arc is the little one. The measure of a minor arc, is equal to the measure of its corresponding central angle. Is equal to the measure of its corresponding central angle. The measure of a minor arc is equal to the measure of its corresponding central angle. So, we said the measure of angle A was 80 degrees. Okay? The measure of the arc, BF, to show it's an arc, we just put a little arc above BF, imagine that, an arc. That is 80. But there's no degree. Okay, the angle has a degree sign, the arc does not. Okay, so we know that, flip it over. Okay, inscribed. And now our angle looks different and no longer has the vertex on A. Okay, no longer has the vertex on A. The vertex is now on the circle as well. So both endpoints of the angle and the vertex are all on the circle. And notice the angle is on the inside of the circle. This is called an inscribed angle. You've heard that word before, right? We've used it before where it's on the inside, that's an inscribed angle. Inscribed angle. Now this has a relationship too for its arc on the outside. This arc, oops, different color, C to D is not equal to the angle. It's actually twice the angle, or the angle is half. So the measurement of angle B is half the arc C to D. Okay. So an inscribed angle where the vertex is on the circle, that angle is half the length of the arc. So the arc is twice the size. Okay? So if I said 40, the measure of angle B was 40 degrees, what would the measure of the arc CD be? 80, good. So if I put degree sign, I put degree sign on the angle. Okay. A polygon that is, notice the polygon is on the inside, that the circle is on the outside. What's that vocabulary word that for going around? And inscribed is on the inside. What's the word for on the outside? Circumscribed. A polygon that is circumscribed by a circle. You have to write small line right out. Circumscribed by a circle, meaning the circle is on the outside. Has all of its vertices on the circle, and the interior of the polygon is completely contained inside the circle. So circle A is circumscribed about or around that quadrilateral. This solid is completely enclosed by its figure, and so the circle is circumscribed, but the quadrilateral is on the inside. So we're going to say the quadrilateral is inscribed, yep. The solid is an inscribed figure. Inscribed. Yeah, that wins. That makes me dizzy when it shakes a word like that. Inscribed figure. So the circle is circumscribed, the quadrilateral is inscribed. Okay. A line that intersects a circle only at one point. So this line with arrows comes by a circle and touches once. What's that type of a line called? Good, so you've heard this before. Tangent line is a tangent line. If it only touches the circle once and brushes off of it and keeps going, it's on the outside. The point where the tangent line touches at one time is called the point of tangency. Point of tangency. Okay. Now, there's an interesting relationship that happens. That tangent line touches, I think that's a B, at point B. If I connect a radius A to B, this tangent line is going to always be perpendicular to the circle right there. It creates a perpendicular intersection with that radius. So add that on to the bottom of the box. A tangent line is always perpendicular to the circle. The tangent line is always perpendicular to a circle. Okay, the last figure, is that a tangent line? Or not? Touches twice. Okay, if it touches twice and continues, if it just touches and stops as a segment, that is a chord. If it continues through with arrows, that is a secant line. Okay, secant line. Now don't flip it over, we're going to add another one on the bottom. Don't flip it over, we're going to add, in this space down here, we're going to add something. Okay, one other angle. To review really quick, on the front side, this type of angle, central angle, with a vertex on the center, that is equal to its arc, right? They're equal. This one at the very top, an inscribed angle with the vertex on the circle instead of the center, that angle is half of the arc, where the arc is twice. Now we're going to add a third one where the angle is actually on the outside of the circle. So what's that word for outside a circle? Circumscribed. Good. So last one on the bottom of this page is the circumscribed angle. Circumscribed angle. Okay, we're going to draw a picture. As best you can, draw a nice big circle. That's actually a really nice circle. Not too bad. With center point. Okay. Now, circumscribed angle is an angle whose rays are tangent to the circle. Circumscribed angle is an angle whose rays are tangent to the circle, which means they can only touch the circle once. And it has to be on the outside. Tangent lines have to be on the outside. So if I do a tangent line that touches one right there, and say this is the outside point or vertex of our circle or angle C, man, that board is shaking. It must be really windy out there. It's making me dizzy. Okay, and then I extend my angle so that both rays only touch the circle once. Okay, so both of those rays are tangent. And give me two letters I haven't used besides the C. Z and G. Okay, those are 2 points of tangency. Z and G. Okay, for a circle, and how about? Now remember, each of these tangent lines run, how do they intersect the circle? Perpendicularly. So that's perpendicular. M to G is perpendicular to our other ray. Okay, and another relationship that happens, actually, there's only two things we're going to write down. Z to C, that segment is going to end up being congruent to the other segment, G to C. So our vertex to both points of tangent C create congruent segments. So we get the two tangent segments. The two tangent segments will be congruent. In this case, segment VC with a bar above it is congruent. I put parallel. I shouldn't put congruent. It's congruent to segment GC with a bar above it because they're segments. Make sure you write this down. Okay. And then there's also a relation that happens with the arcs. Now we have two different arcs here. We have a minor arc right there. It's a smaller one, right? And we have a major arc out here. The measurement of the angle C is going to be half the difference of these two arcs. What does difference mean? Subtract. So we're going to subtract the major minus the minor and divide by 2 when you know the measurement of angle C. So the measurement of angle C is half the major arc. Now, we actually need 2 more letters in order to label this major arc so we know which way we're rotating. Because I can't just say ZG, because both arcs are actually ZG. Okay, so I need one more letter out here. What letter do you want? Okay, I heard Y. I heard a Q as well. And I heard W. What is the W in the minor? Okay, so if I have one more point that I know which way I'm rotating, I'm going to move from Z to Q to G. So that's going to be my major arc. Z, Q, G. My major arc minus my minor arc, which now I have 3 letters so I know which way I'm rotating. Z, W, G. Okay, when you subtract them and divide by 2, you know your measurement of your angle C. Okay, flip it over. Almost there. This one I have to reopen. Okay, so central angle. Once again, central angle is equal to its arc, the intersectional arc. Central angle, a quick section, so you remember what central angle is. Central angle has to be of the vertex at the center. An inscribed angle is half of the arc that it intersects. So here's the arc, the angle with the vertex on the circle is half the measurement of the arc. Okay, radians to degrees. We say your calculator has to be in degree mode to use your trig function, sine, cosine, tangent. Well, radians is another measurement of around the circle in degrees. One rotation around the circle is how many degrees? 360. So, let's see. I'm going to actually add a page here. You guys don't have to write this down. Here's my circle. I need my pointer. Oh no, what am I? It disappears. Okay. I want you to pay attention to how many times my keys go around the circle. Here's one length of a radius. We have this thing called a radian, and really next video I'll work with this more. But this is a very quick and watered down version of what a radian is. Okay, here's the length of the radius, right? With my keys, which I just erased part of it. Okay, I'm going to bend this radius around the circle. Count how many times it takes for me to get around the circle. 1, 2, 3, 4, 5, 6, and how much? How much is that? Right. How much of this? Oh, that's really close. It's actually 0.28. 6.28. Does that look familiar at all? Yeah. It's 2 pi. So one full rotation, 0 degrees, if you go all the way around, is called 360 degrees. But in radians, we start with 0 pi, go all the way around, you get 2 pi. So halfway around, 180 degrees is how many pi's, and all the way around is 2 pi. 1 pi. 1 pi. Okay, so if there's a pi involved, you're in radians. Okay? That's your quick version of what a radian is. Okay, guys, stay with me. 5 more minutes. 3 more minutes. 3 more minutes. Please, enough, like 3 times. Okay, a radian, we're going to convert 50 degrees to radians. You have like chemistry, you practice converting between units, and you have to have one on top or one on bottom in order to cancel out the little unit. So my degree is on the top, and let's have degree on the bottom. It's easiest to work with 180 degrees. What's 180 degrees version in radians? How many pi's is that? 1 pi. So this is a fancy form of 1. Pi divided by 180 is just 1, because pi is just the radian equivalent of 180 degrees. And so my degrees cancel out, leaving the pi. In my calculator, I would type in 50, you should be writing. So my calculator, I would type in 50 divided by 180. Do you know how to simplify fractions? Math, enter, enter. And I get 5 over 18. But the pi, I never actually type into my calculator. My radian has to have the pi symbol. So it's 5 pi over 18. I did that by dividing 50 divided by 180. And keeping it a simplified fraction. So we'll look down below at number 1. converting to radians. I have 135 degrees, and then times by a fancy form of 1. So I need degrees on bottom in order for my degrees to cancel out. So what's the degree I used up above? 180. Technically, you could use 360, but that just means you have to use 2 pi. So we generally use 180. 180 is radian equivalent is how many pi's? 1 pi. So pi goes on top. So take a calculator and do 135 divided by 180. Do it, please. 135 divided by 180. Math, enter, enter. Good. 3 pi, don't forget about the pi, over 4. Now reversing, converting instead of radians to degrees, you still have this fraction. I'm going to do 7 pi fifths. So this is a radian because there's a pi in it. So if I need the pi to cancel out, so I'm no longer in radians, I need to make sure my pi is in the denominator. What's pi's equivalent in degrees? 180. So the pi's cancel out. I do 7, oh, hold on, 3 seconds. 7 pi times 180, and I get 252 degrees. As you need, I'm going to be giving you your homework packet on circles. Notice the circle ones are required, the others are extra credits. Make sure you come out this way, please. Come out this way for your packet. The circles are required, the others are extra credit. The green one I need next time. I don't think we will on the questions. We'll probably have to turn them in. So out of time. Make sure you bring this way for the packet. Put it in the third for them. Let's see this packet. Certain ones are required. Those are extra credit. Fine. Don't forget about sage, so that's going to end soon. There we go. Oh, sorry. Good catch. Finger down. You know that one, right? Yeah. Do you do one? Okay.